with limits, there are two basic types of limits that you're asked to evaluate. One is the limit as x approaches some real value, and we'll call it a, of the function. And the other type is the limit as x approaches infinity, or a very, very large value of the function. So there are two types. There are some you should know, some limits you should already know. So if a and k are real values, the limit as x approaches a of just a constant. So obviously as x changes, the constant's always going to be k. The limit as x approaches a of just x has got to be equal to a. An infinity one, the limit as x approaches infinity of a being a real number, over x. Now as x approaches infinity, getting very, very large, well, that will approach 0. The limit as x approaches 0 of sine x on x, that's just one that you need to know. There is some detailed explanation in your notes, so I won't go into that, but this is one you should always remember. Sine x on x is equal to 1. And the limit as x approaches 0 of 1 minus cos x on x is equal to 0. Obviously, if you just try and put x equals 0 in these, it's not going to work because you're going to get divisibility by 0. So these are ones that you can just state without any proof. Now, strategies. So we'll go back up here and just look at two ways to actually do these. So strategies. So we've got two different strategies. For x approaches a, if you try substitution first, and that's just putting x equals a. Now if it works out to be a value, well that's fine, you've got the limit. If you get divisibility by 0, so you get some value on 0, so this can be any value. So if you get any value over 0, try cancelling down. And that is like factorisation, so algebraic using algebraic factorisation. And I'll do an example of one of those a little bit later. So if you get something divisible by 0, try and factorise. If you've got a numerator and a denominator, try factorising the numerator and denominator, and then try and cancel down some of those factors, and then do your substitution in, and you may be able to alleviate that. This one here, the x approaches infinity. Once again, try straight substitution, and just use very large numbers for x approaches infinity. However, and the other thing too is to bear in mind that you've got the one you should know down here, number 3. So as x approaches infinity of that is equal to 0. So if f of x is like a fraction, so you've got a numerator and a denominator, factorise and take out. So you've got a numerator and denominator, take out the highest power of x. So for instance, if you wanted the limit of x squared minus 1 over 4 x squared plus 3. So you want the limit as x approaches infinity. So that'll be the limit as x approaches infinity. Now the highest power of x is x squared, 1 minus 1 on x squared will be my factorisation of the top, taking out the highest power of x, so it's x squared, so x squared's common up here, and down here it's the highest power of x. Down the bottom we've got x squared outside of 4 plus 3 on x squared. These x squareds will cancel. And now when we substitute in, you keep writing limit till we substitute in. We know that the limit as x approaches infinity of a over x, or a over x squared. So we're going to have 1 minus, now when we put infinity, 1 over infinity squared is certainly 1 over a very, very large number. So that'll be 0 over 4 plus 3 over a very large number, 0. So we'll get a quarter. Okay, so there's some strategies to try and solve these limits. These are ones that you need to know.